Ladies and gentlemen, distinguished guests and fellow participants, I'm honored to stand here before you today to introduce our distinguished speaker for the opening plenary or keynote session of this very relatable conference. Today we are here to reflect on the 16-year journey of the UT Austin Portugal program, to draw upon its accomplishments and ideate on an ambitious future. At this intersection of reflection and foresight, we are privileged to have with us an individual who embodies the spirit of innovation, research excellence, and transformative thinking. Professor John G. Ekerdt is an accomplished academic and visionary academic leader, combining experience in leading and research aspects of a School of Engineering, a Department of Chemical Engineering, and interdisciplinary research programs with a passion for teaching and education and a sense of duty to build excellence and serve others. He is Norbert Dietrich Welch Chair Emeritus in Chemical Engineering and most recently served as Associate Dean for Research in Engineering at UT Austin from 2008 to recently, 23. He received his PhD in 1979 from the University of California, Berkeley, and his career is marked by significant contributions in the realm of chemical engineering. With a Scopus Index of 53 and more than 300 peer-reviewed publications, several books and 9 US patents to his name, his work has been instrumental in unraveling complex reaction pathways, mechanisms, and rates in the domain of surface, growth, and materials chemistry of metal, dielectric, and perovskite films and nanostructures. Professor Ekerdt's influence extends beyond the realm of research, manifesting in significant administrative and educational impacts. He has nurtured the intellectual growth of numerous students, supervising over 60 doctoral students, thus playing a pivotal role in shaping the next generation of thinkers and innovators. Now allow me to share with you Professor Ekerdt's talk's abstract, which is titled succinctly as Our Energy Future. Climate change, energy security, energy equity, and sustainable growth are major drivers for shaping our energy future. Green hydrogen will be pivotal in addressing these drivers. Hydrogen is needed in decarbonizing manufacturing processes through electrification and transportation sectors, directly or through electrical vehicles. Long-term hydrogen storage and chemical conversion of hydrogen to alternative liquid fuels, including methanol and ammonia, can overcome the intermittency or variability of solar and wind power. Portugal and Texas have an abundance of solar radiance and wind, providing the energy to produce green hydrogen through hydrolysis, and are natural partners to advance this energy future. Our academic institutions have the expertise to undertake the necessary research and infrastructure to educate the workforce who will ultimately lead this energy future. This energy future will require an ecosystem that values fundamental research, fosters innovation, and encourages startups. Our distinguished guest's discourse promises to navigate the intricate landscape of climate change, energy security, and sustainable growth, underscoring the pivotal role of green hydrogen in decarbonizing manufacturing processes and transportation sectors. Professor Ekerdt's insights will offer a reflective exploration of the potential synergies between Portugal and Texas in advancing a future where our energy ecosystems are resilient, equitable, and sustainable. Now, I'd like to pose 2 questions for your thoughtful consideration during the presentation, which you can access using the QR code. Was that coming up? Good. So question 1, in shaping our sustainable energy landscapes, how pivotal role do you envision hydrogen playing as an energy vector in our collective future? And question 2, we are evidently not on track to meet the UN's 7th Sustainable Development Goal, which aims to ensure access to affordable, reliable, sustainable, and modern energy for all by 2030, which is just a handful of years away. However, do you believe that this pressing issue receives adequate discussion and attention from those empowered, those people in here, to steer the energy transition? With these questions in mind, and without further ado, let us extend a warm welcome as we invite Professor Ekerdt to take the stage and share his invaluable insights. Professor Ekerdt, the floor is yours.
I'll get water if I need it. I'm going to use this mic. Okay. So I want to spend a minute, first of all, oh, there's a timer on here, so this is good. But you wave your hand when I've got 5 minutes to go. Thank you. So I want to say a few things personally about me with energy. When I started graduate school, I know many of you wouldn't have been around then, but this 1974, the Arab oil embargo, United States was like, what are we going to do? We can't put gasoline in our cars. And so I worked on a problem that was liquefying coal to make synthetic fuels that you could make as an alternative to petroleum. And here I am, so many years later talking about our energy future. That was really addressing an immediate problem. We have an immediate problem with energy, but we have an existential problem. And this is really, I think, it leads into sustainability and the climate. And so energy and how we approach energy is really for our economic growth now, our prosperity now, but really for the future generations. So let's talk about our energy future. I want to say a few things about the urgency of this problem. I know this is, you know all these things, but let's talk about the urgency a little. We'll speak a little bit about, I'll talk a little bit about energy and economic growth. And then finally, we're going to talk about looking forward. This is all about looking forward, this whole meeting. So let's spend some time with that. So, wait a minute. Okay. So there's a few things that are important. Energy security. And I thought, well, I found some recent articles. In fact, the one on the bottom was just in a local paper from Austin on Sunday. And it's really about nation states acting badly. And then what does that lead to? This leads to scarcity of fuel and scarcity of energy. And so we've all, you've experienced this more in Europe and in Portugal than we did in the United States, but cutting off supplies or restricting supplies and how these economies have adapted and the costs and the economic disruption that that's caused. And then the issue with the events going on in the Middle East now, and this can change the ability or the willingness of certain nation states to transport energy. And all it takes is a little disruption and the prices spike, costs go up, and so it's a real problem, all right? So energy security. We want to be secure in the energy that we use within our borders. The other one is climate change. So I have a few a little closer to Portugal here. I have a quote on the climate change with respect to fires. You're aware of this big problem of fires here, and somehow or other, I will connect it to climate change, right? So it is an issue, and people can debate that point. And the other one is the fires, and then just really these two quotes dealing with fires in Portugal. And then the third one on the bottom deals with sea level rise. And I tried to find some maps of sea level rise, and they look really bad in the United States because of the coastal plains and the population centers near the coast. And I tried to find maps of coastal change in Portugal, and it didn't look like, I don't know if how you're affected by rising sea levels. Maybe the elevations are too high relative to the sea, but it's a really big problem in the United States. So this is a problem. And then here's an image of a glacier in Italy, from 1933 to 2012, right? You all know this. Like, stuff is melting, sea levels are rising, Arctic shelves disappearing. So it's a problem. All right, energy. Energy's, we need it, right? It makes us healthy, wealthy, and free. I mean, this is an obvious thing, but it's done right. Done wrong, or when we think about energy and energy equity, it's not uniform. And there are populations that don't have access to energy. There are populations that are impoverished because of energy. Energy is connected to economic growth. They're intertwined. And so this is a real problem, another urgent issue of energy equity. So here's some feel good. Energy is good. You know this, right? But it leads to these important aspects that are important to us, really our ability to prosper, and it's interconnected with energy. You can't uncouple these two. So here's a slide of, and I want to recognize the Weber group. I had his name on here. Michael Weber, I appropriated, he gave me his slides to use, right? So I appropriated a number of his slides. And so the slides that his group prepared, there's this little logo around the bottom. Anyway, here, this shows energy consumption per capita, and GDP and energy consumption. There's a rough correlation, and Portugal's not on here. I have a next slide that sort of puts some of Portugal in perspective with regard to Italy and France. So see where Italy and France are on here. And the next slide, different years, different set of numbers, but Portugal is here in terms of energy per capita, and France and Italy are right up here. So you're above the line. I'm assuming you're above the line. I didn't do this plot. So it's related. This we'll accept. So we need energy for economic prosperity. We need energy for the well-being and prosperity of our countries. So it touches everything we do, right? It's important for transportation, electricity, water, food, and it's important for public health, national security, education, our freedoms. It weaves us all together. It allows us to be what we are as societies. There are many more things allow us to be how we are as a society, but energy is fundamental. We'll agree with that, or I'll advocate for that. So there are trends that are changing. These are major societal trends, right? And so energy and society, they're just interconnected. But as populations grow, as economies and these populations yearn for economic growth, they're going to need more energy. As people move into urban centers, they're going to need more energy in these urban centers. It's driving demands for energy. As economies grow and industrialization moves forward, there's needs for electrification. And then finally, Brian was asking me, what does motorization mean? Well, you're moving from donkey carts to cars, right? And it's just, you need energy, right? And so not hay to feed the animals, but energy to put in to make the cars go forward. So energy is critical to all of these. And the world is moving in this direction. So some technology trends, decarbonization, lowering our carbon footprint, CO2 sequestration, quit putting so much CO2 in the air. Decarbonization of our economies is critical, and that's one of the issues that we hope to address. Digitalization, the more information you have, the more efficient you can be, the better you can be at planning. And then decentralization. Everyone wants a solar cells on their house. They don't want to pay money to the company that's providing this. So small grids, microgrids, larger grids. So decentralization of energy. It's a trend that's happening. So let's think about, oh guys, look at the slide number here, right? She knows how many slides I have. The world, there's three problems that have to be addressed with this energy, right? So national security, it's important to our national securities. Energy security is one of these, but national security, the environment and supply and economies. These are intertwined. And we have to make trade-offs in some of these. And so as we address this, we have to keep these in mind as our nations do, and our leaders take care of, manage all of these aspects and balance these. So we have to have trade-offs, right? And we have to have an understanding. If we're going to have these trade-offs, our society needs to understand energy, how we use energy, the importance of energy. And more than just what does it cost when they have to put fuel in their tank or they pay their energy bills once a year or once a month, right? So it's important for us to be advocates for educating people around energy and how energy affects our lives. So let's look at fuel mixes. And this is a slide that shows, let's say, USA and world consumption. And I want to point out that these are two different values here. And so the US represents about 16% of the total. And then, as an example, then about 35% of the oil consumed out of this 16%, right, is what goes on in the United States. So as you look at these, there's different total amounts. But it's not dissimilar, right? There's quite a much more coal is used worldwide than in the United States because it's blessed with oil and natural gas, but the rest are pretty common, all right, across our economies. If we look at consumption by type, right? And this is going from 1980 to about 2020. Renewables increasing, nuclear's increasing. Coal continued to increase over those years, right? Because we saw that on the previous slide. Coal was a large component of many economies. And so how do we get coal out of the global economy? And then natural gas and petroleum. So let's look at the next one, closer to home. This is what's happened in Portugal between 2001 and 2021. And I stole all these slides out of one of the reports that came, Energy and Numbers, right? So the point is, and this only looks at petroleum, electricity, natural gas is here, renewables, thermal, and then everything else that's other, biomass, you name it. Anyway, the point is, the energy, the total amount of energy may have gone down, but the percentage that has gone into renewables has increased, I think. And there's this push toward renewables, right? So this trend upward in renewables here in Portugal as well as worldwide, right? And so this is just a snapshot between those 2 years. If we look at energy, and we think about energy and the interconnectedness, this is a busy slide, so there's not a test later that you have to remember all of this, but the point is here's renewable energy, and this is the US primary energy consumption, by consumption. And 60% of the renewable energy ends up going into the electrical system. And then that electrical system ends up going back and up over here. So as you trace these around, 9% of the 20% of the energy goes to industry directly, and then some goes indirectly. I think what's interesting is that the renewable energy, about 5% directly goes into transportation, right? And the rest it leaks in through the electricity if you're charging batteries, right? So there's a lot of areas for increasing the role of renewable energy and decreasing the contributions that petroleum and natural gas make to our energy supply. And that will make us, well, it will make us more energy secure and will reduce the carbon footprint. Well, all right, so we know this, but we had this on an earlier slide about energy equity, but there are great inequities in the distribution of energy, or not the distribution, the use of energy across the world. And you can see the global average, and here's the energy hogs here in North America, well, leading the pack here. But the point I want to make is that, there's a lot of, as these economies and these populations grow, they're striving to push this number out, their numbers out here. And so we will need more energy. It's just inevitable, right? And you can't have economic growth without energy, and they are yearning for economic growth. So it's going to happen. We just have to be prepared for this, and we have to have systems in place that allow this economic growth, worldwide economic growth in our countries, to be sustainable. And this is what's pushing us, I think, as we explore things. I'll pick the theme renewables, but it's really green hydrogen is the theme that I want to drill in on in a minute. So we're going through transitions, and how much time have I been talking? How many? Okay, I have time, all right? Okay, it's slide 21. Okay, we're going through a transition. So let's look at U.S. carbon dioxide emissions with consumption. And we have these dips, right? And it's, well, we're doing well, and then we have to use different fuel sources. But the point is, everyone's been focused on bringing carbon dioxide down, and we hope this is just another one of these blips that went up in 2021, and it keeps going down, right? So carbon dioxide, bringing it down, but we're not bringing it down fast enough. I think people would argue that. Let's look at renewable energy. And this is the U.S. in 2021, and I have some slides on Portugal in a moment. But let's look at how energy has evolved in terms of, just from the renewable sector. And you can see the large growth in wind and solar. And, biofuels, there's a lot of activity trying to develop biofuels, and it bounces around. But it's really, the great growth in solar and PV, and particularly in Texas. It's a phenomenal amount of energy produced in the state of Texas from wind, because they have vast tracts of nothing, and you can put farms, huge farms of wind farms out there. The Gulf Coast is going to start populating with wind farms. So it's a future direction, I think, for more and more wind being a component, and then solar being a component of the energy mix in the state of Texas and in the United States. Well, let's look at Portugal, going back to your energy in the numbers report. And so we're going to look from again, this is a comparison across these 2 decades. And so we have petroleum and coal, and then the renewables, and then natural gas, and then everything else. Killian was looking at this, and he's telling me this, he's giving me the subtleties of this, and I only wanted to point out a few things, and we can talk about this later if you want. But again, the point is that renewables as a percentage of what we're using, or what you're using, or what you used is increasing, right? So we all have recognized renewables are important, and Portugal has recognized renewables and is committed to this movement toward renewables and green hydrogen. So what are the critical technologies? And I'm only going to focus on one of these, but you could drill into many of these. So what are our options to make things more, oh, I can't point at that. Things facilitate efficiency, right? Some of you work from home, right? And you're glad to be back in the office, but you need broadband, right? And so advancing broadband and mass transit and urban planning, leading to redesigning cities. I don't want to drill into all of these, but tools for electrification and microgrids. There's a huge program in microgrids and grid electricity here in Portugal. Carbon management, capture, circular economy. I want to focus on green fuels. I want to focus on green hydrogen specifically, really for the rest of this, my presentation, right? So this is an emphasis that we are all working toward, and I propose is something we should continue working on together. And not just using, but it's clean hydrogen at scale and economic. So it's not enough to just I made hydrogen. Can you do it at scale, and can you do it that's cost effective and competitive with someone's going to give you a tanker full of natural gas? Can you use the clean hydrogen instead of burning the natural gas? So it's got to be cost effective. I mean, it's got to be economic. And then there are other ways of using hydrogen, not just directly using it to produce electricity, but maybe putting it into liquid-based fuels that you can ship around and use, or make hydrogen-based chemicals. Well, all right, so what's in your future? And I was provided another report, right? And so this is what your government says you're going to do. They're going to promote the decarbonization of the economy and the energy transition. I'm going to read it. Aiming for carbon neutrality in 2050, based on a democratic and fair model for territorial cohesion that enhances generation of wealth and efficient use of resources. All very noble, and Portugal is making a lot of advances in that direction. So so that's the vision, but what are the goals? So I had to put this in English so I can read what's going on here, but I gave you the Portuguese version, right? But renewables, 47% of the energy. And there's some debates going on that number should be even a little higher. Transportation, 20% of renewables feeding the transportation sector. I'm sorry, I'm in Brian's way here. I'll get out of the way. And then emissions, reducing emissions. So these are big goals that Portugal has set for itself. And if we work together, as we work together, we can help Portugal realize these goals. We can help Texas and the United States reach the goals that it has. So what is Portugal doing? So there's an article that was published out of Ekerdt, and you can read the title here. And I just took a quote out of the beginning, and I know this is like, they're writing the article, so they're going to promote what they're doing, but I think it's very powerful, right? And the points made is that Portugal is at the forefront of the EU countries in this activity. And the roadmap, I shared some of the roadmap, and a commitment to working on clean energy and hydrogen, right? There's this deep-seated commitment. So whether you want to do this or not, it's happening. So get ready, right? And continue to contribute to this. So this study, this article, went on to do a case study. And the case study, as said, was let's look at loss of load expectation. So one of the problems with renewables is the intermittency of power, right? Sun sets every night, wind dies down, and so you need storage. And you can store energy in batteries for some period of time, but you need long-term storage and load leveling for across grids. And hydrogen could be and is likely to be that solution. There are other ways to do this, but hydrogen's a way to do this. So what this study looked at was, let's take the installed capacity, and then there was some model for what the power system had to be. This was feeding all of Portugal, and you're trading power back and forth with Spain. You're shifting between the different energy sources, and what is it going to take in that mix to get there? And the point was, you were going to need a lot of wind and a lot more solar than where you are now to make this work. So the role of renewables in reaching and meeting this scenario shows the importance of renewables. And then they advocated for, you make more hydrogen than you need and you can store it. There are salt caverns available geologically to Portugal to store this hydrogen. And so you can put it in, you can make the green hydrogen using electrolyzers, and then you bring it out with a fuel cell. Well, or you can use PV. So the point being is that long-term storage as the gas, right? That's what they did. So UT in Portugal, and what's important here is we're natural partners in this. We are. We also have the UT Portugal program, so I actually advocate for we're natural partners, but we're natural partners in this. And I've listed a few laboratories and programs in Portugal that map onto what we have and the expertise. We heard Peter Artsberger talk about this. Jose talked about this. The subject matter experts, bringing them together to work on problems. And so the subject matter experts and public-private groupings of researchers in Portugal and in Texas, and bring this together, and we'll be unstoppable and make great advances. So the High Lab CoLab, the Green CoLab, and the Smart Energy CoLab, combined with an S-Tech. And if I didn't mention the labs you're associated with, I'm sorry, I ran out of space on the slide. But there's a lot going on here. That's what my point is. So what do we have at the University of Texas? We have an Energy Institute. Brian Korgel's the director. We have a Bureau of Economic Geology that deals with large-scale systems. Well, inside of some of these institutes, we have hydrogen at UT. And they come together, they convene, they've been doing this for years, and they talk about what are the programs in hydrogen? What are we doing in hydrogen to advance this technology? And so we do this once a year. There's some programs. We just received funding for one of the hydrogen hubs from the Department of Energy. And there's a Gulf Coast hub, and the University of Texas is the academic lead in this hub. There's an energy development lab, PEDAL. I have slides on each of these. And then finally, solar. So we have large public-private groupings of people. We have the subject matter experts that are behind these programs. So let's look at PEDAL. And why is PEDAL important to the discussion of the UT Portugal program and to advancing this forward? So PEDAL is it's really to set up an innovation hub in the Permian Basin. So Texas kind of goes through here, New Mexico comes in and does this. It's hard to see it on here. But the Permian Basin, vast amounts of oil, vast amounts of gas, right? Huge. But if you go out there, all you see are cactus and oil wells. So how do you bring economic development to this? How do you bring innovation together around this? How do you bring these communities forward around energy and these new forms of energy? And so PEDAL is really to deal with these innovation and workforce development. And we're at the starting point of one of these, this PEDAL, and then if you renew and you get invested in the whole program, then spending on steroids on this particular project. But the point is it's established innovation hubs. And something similar, it's not like the U10 program, but innovation around energy, right? This is a good model that we can learn from. The hydrogen hub. These are huge investments, and companies lined up, and they elbowed other people out of the way to get these. And so one of these is in the Gulf Coast. And the issue for the hydrogen hub, they have a target, and let me make a few points. All right, it's hydrogen at scale in the Gulf Coast, right? And the Gulf Coast uses an immense amount of hydrogen in chemical manufacturing, but they take natural gas, they reform it, CO2 goes up the stack, right? And so how do we do this now where we make the hydrogen, but we make hydrogen with not more than 2 kilograms of carbon per kilogram of hydrogen produced and reduce the cost to $1 per kilogram in 1 decade. That's their goal, right? This is very ambitious if you're going to do blue hydrogen, right? And we're advocating green hydrogen. So this program, Texas has a lot of natural gas. So naturally, this program is going to necessarily begin with more blue hydrogen than green hydrogen. But what we learn about hydrogen and hydrogen markets and developing hydrogen markets, I think, is relevant to what's going to go on here. And Brian Korgel is again, he's connected to everything, right? He's actually in the same department I'm in. So I'm connected to Brian through this. So we're all connected to Brian, and he's the institutional lead for this for us. And UT's involvement in this, they're not supposed to be doing research, but you know research is going to go on along the way. It's techno-economic and life cycle analysis, and importantly, workforce education and development. And there's components of workforce development that are needed, and so programs that are developed in here on workforce development and education, both in PEDAL and this, I think are relevant to how do we extend these and expand these to Portugal. All right, hydrogen storage. So this is a diagram from that paper, right? And there's 300 storage capacity for 300 terawatt hours in salt domes in Portugal. I think that's a big number, right? Someone might tell me, Killian, is that a big number? Yeah, probably, no. Yeah, it is, okay. So anyway, there's a lot of hydrogen produced in Texas, and this is something out of the high velocity, but how do you move the hydrogen? How do you use the hydrogen? How do you develop local markets for the hydrogen, right? It's not just use it directly to produce electricity, but other uses, and that's what the hydrogen hub is. And so I have a diagram here, really, that links Portugal to Spain and Portugal to perhaps markets that could use ammonia, if you're making ammonia, so there's a lot of opportunities for hydrogen beyond just making electricity. And you're storing hydrogen in salt caverns, and there's a huge program at the University of Texas run by the Bureau of Economic Geology that focuses on where do you store it and where is it going to be used, how do you use it, you make electricity, you have to use it sort of a point of source. And so these are important variables that need to be brought into the economic analysis and the life cycle cost of hydrogen. And these programs that I'm talking about here are present there. All right. Challenges. So we're going to make hydrogen, and then we're going to use the hydrogen to produce electricity, and so we can use fuel cells, or maybe you're going to make methanol and use a methanol fuel cell. So what are the challenges? Where are the research? So I was talking about a lot of programs. These are techno-economic analyses that need to be done on the large scale, but on a smaller scale, let's bring it down to the smaller scale for a moment. So there's a lot of work that needs to go on in membranes, right? And then there's in the catalysts, perhaps the nanomaterials and the catalyst, but the membranes. Nafion is the great membrane for using for proton exchange membranes and for these solid electric fuel cells. Well, Nafion isn't all that it works, but you have to keep it below a certain temperature. You have to keep it hydrated. There are problems with Nafion, but people are like, I don't like it, but I have to use it. So if you had other materials that could operate at higher temperatures under these aggressive environments that are present in these, you could make great advances forward in fuel cells, right? This fuel cell technology. If we talk about electrolysis, right? So we're going to have electrons coming out of solar cells, we're going to have electrons coming out of windmills, and we're going to make hydrogen, and we're going to make green hydrogen by taking water and splitting it. So the next generations, as we move forward, right, we're sort of here, right? Well, we're sort of here, right? This next generation, scaling up, durability, cost effectiveness. So some of these are just mechanical design, but then where are the advances where are some of these advances needed? And some of these advances are clearly needed in the membranes, where they use the anion exchange or the proton exchange. So present membranes, 30,000 hours. That's a long time, but you know, they build a power plant and they last for years and years and years. That's more than 30,000 hours. And so membranes that don't break down, the polymer backbones don't break down. So new materials for membranes, right? This is a pressing need if we're going to move toward green hydrogen using anion exchange membranes. And here's the proton exchange membrane. Here's the diagram. Again, it's our friend Nafion. If you could increase efficiencies, if you could get away from Nafion and use a thinner membrane that had the same mechanical stability, so your efficiencies would go up, and then you would be a hero, right? So new materials, clearly new materials are needed. Let's look at this one, photovoltaics, right? So we're going to bring, sun hits us, sun hits the solar cells, and how do we move to efficiencies that are approaching 30% or greater than 30%? What needs to be done? Well, what needs to be done is we need to move to monolithic perovskites integrated onto silicon. So solar cells, there's a lot of problems, not problems. There are challenges in building the system, the cost effectiveness of the whole package, all of that. But advances in perovskites and cost effective perovskites, cost effective in terms of available and I guess it's the availability, the elements that go into these perovskites. So a lot of work needs to be done in perovskites. And there are programs at UT and the solar, what is this? Solar photovoltaic 2050, I guess. Yeah, okay. Okay. Guess who's in charge of that one? All right, raise your hand, Brian. Okay. So if you have questions about these, Brian can answer them. But my point is that if we're going to make green hydrogen, where are there research problems other than the socioeconomic problems? Well, membranes, and let's look at the future next generation solar cells for high efficiencies. Okay, lastly, we have to change technology, and the technology we have to change, if we're going to electrify, then let's think about where we spend a lot of, we just throw energy away. And we throw it away when we make electricity. And if you look at process heating across a number of areas, chemicals, iron and steel, food and beverage, petroleum refining, forest products, and cement. Huge thermal demands in the processing, right? And what the Department of Energy's invested in is called an innovation center, EPICS is the name of it, and it's based out of the Arizona State University, but the Chief Technology Officer for this program is Michael Baldea. He's at the University of Texas at Austin. And there are a series of test beds to lower to electrify processes. And in doing so, you will eliminate huge amounts of carbon dioxide emitted into the air. And so how do you electrify these processes? How do you re-engineer these processes? How do you think about running these when you're electrifying them? Instead of heating everything up, heat it up locally and deal with the intermittency during the processes. That's what this is going to look at. And so here are other areas where we can, as we electrify things, then we have to rethink many of our processes. And these are sort of fundamental to our economies. So let me summarize at the end. I'm going to tear up when I get going on this one. But I think this, you know, if we we have collaborations, and I think if we mobilize the competencies in Portugal and at UT Austin, and we couple education and the research missions, this is what we do in academia, and with innovation, right? Then our goals of decarbonizing and becoming leading renewable centers that have renewable energy based around hydrogen. We can achieve this, right? And so this it's not inevitable we're going to get there, but if we work together, we can get there, all right? So I think our partnership can make a difference, and around renewable energy that's sustainable and accessible for all. These are goals that our societies and our national agendas, right, demand, and they've asked for this. And so we should be at the forefront of leading this forward. All right, Portugal's been playing a leading role in this transition, integrating electricity with renewables. I shared some of those results with you. I'm sure others in the audience are aware of more examples, but this is an important theme. All right, and then Texas is uniquely positioned as a partner in clean energy. And I shared with you a number of programs that we have around clean energy that are public-private consortia and the subject matter experts between these two countries. I think that this is really an opportunity that's being afforded us because of our unique abilities, our unique geographies, our unique capabilities with regard to natural resources that we are blessed with, that coming together, I think, and addressing this as a group in partnership, I think is where I'd like to leave this. So thank you.
Thank you, John.
Supposed to sit in one of these?
I think we can sit. Yes, please. Okay, so before we move on to the Q&A, I would ask to put up the two questions I posed before the talk, in case anybody missed that, and they can still have a chance to answer the questions. Okay, all right. So we'll come back to that further ahead. So John, thanks a lot for that.
Thank you.
Really good talk. I was hearing really good comments by my side, people loving your talk. I think before I could start my questions, I was just wondering if anybody in the audience has any pertinent questions they'd like to ask John. If so, put your hand up, and I think a microphone will come to you. No? Okay, I'll break the ice then with some questions on my side. Okay, so...
These better be softballs.
Yeah, okay. On slide, is it possible to bring up the slides again? Okay, slide 17. Okay, slide 17, is it possible to show up slides? If not, yeah. Okay, I was quite interested with this one, where I saw a constant increase of nuclear from about 2000. Did that attract your attention at all? Or?
I didn't put these, I was surprised to see that myself, right?
Okay.
And I know there's been a lot of decommissioning of reactors in some countries, and that's what's going on in the United States, but that caught my attention, so.
Yes, I think that's basically China bringing a lot of them online, and they're bringing them online quicker than we are decommissioning them in the Western Hemisphere.
So I will say that, the advances in, or I guess, use of small modular reactors is a possible application where it's still nuclear power, but it's done in a more cost-effective, and it's closer to where you're using it. And there are beginning to be some commercial small modular reactors that are being placed in the United States. And so I think as the registration or the certification of these reactor systems becomes sort of entrenched through like the Nuclear Regulatory Commission, we probably will see more nuclear, small modular reactors in the United States.
Okay. I've got close friends working on SMRs, and their comments are always regulation, regulation, regulation.
Yes. Right.
It's the biggest hurdle. Okay. If we can move on to slide 20, where we showed energy consumption by different parts of the world. I don't think we need to think of pushing the world average to that number of 200. I think the US and Canada are a bit outliers in their energy consumption. We do have in Europe, which is about half the consumption. I think people live quite comfortably here as well, even with disparities between the north and the south. So it might not be that frightening in terms of amount of energy we need to be able to produce in the future for everybody around the world. I think we can move on to slide 24. Yeah, I think I didn't have time to explain this to John, but the overall decrease we observe here is primary energy consumption. And because there's a large part there which is fossil fuels, they're about 20 to 30% efficient between primary energy and useful energy you can have at the output, whilst renewables are close to 100%. So you get some losses in transport. And so the actual primary or useful energy you're using is actually probably going upwards overall. And it's just transition between the primary energy use to more efficient forms of energy use. So when we look at these numbers where we have to transition from using this amount of energy to a useful amount of energy, it can be frightening, but it's not actually that frightening because a lot of it is very inefficient production of energy from fossil fuels. There is some abatement with that in coal or gas where they also produce heat. And that brings the efficiency high, but heat is a low-value energy source. You can't do much with it compared to electricity, which is extremely flexible.
So let me ask, is the percentage of, this is on a consumption, but renewables are taking more and more, picking up more and more of the energy supply?
Yes, yeah. Okay. Regarding, you talked about fuel cells or green hydrogen. I mean, there was a lot of talk about blue hydrogen, and I think that's extremely important for a state like Texas, which has huge resources in natural gas and oil. But a country like Portugal, which doesn't have natural gas or imports natural gas from North Africa, but it's not ours. We can only import it if they let us import it. I think a big focus is on green hydrogen here. So producing it from basically pumping electricity into an electrolyzer and getting some hydrogen out, and then using it again as electricity when we put it through a fuel cell. What barriers do you foresee or do you see in terms of bringing the efficiencies up? Because when I look at the numbers, I see that for every kilowatt hour or for every unit of electricity we can get out of a fuel cell, we've had to produce about at least three units of electricity to produce that hydrogen, which we can use. How far do you think we can bring that ratio down?
Oh, I'm outside of my realm of being able to answer that one. I don't know if any of my colleagues have any input on this. I'm looking at my
I think
Can you speak up? So we have a microphone for, I don't know the answer.
Yeah, I mean, I'm not sure I have a great answer either, except that I think in terms of the cost of green hydrogen or hydrogen from electrolysis, water, and all of that, technologies are going to advance. Manufacturing costs will go down as the technology scales. So there will be improvements of efficiency over time, but there are some significant bottlenecks in terms of what catalysts you're going to use for electrolyzers. Are those sustainable when you are making massive amounts of electrolyzers? So there are challenges with efficiency, but also just sustainability of some of the technologies. And then in terms of carbon footprint, I think it depends on where you get your electricity from. Might be different in Portugal versus in Texas, our grid is not particularly clean. So how do you do green hydrogen, install more solar, more wind to keep up with that production? So there are a number of challenges related to that for sure.
Okay, thanks, Brian.
Wait. Dan has a comment or a question? Both.
So, John, you talked about green hydrogen, and it's one of the two approaches to deal with essentially intermittency in renewables, right? Is we need to store excess capacity somewhere and then use it later, right? The other competing technology, which we've also worked on in this collaboration, the UT Portugal collaboration, is battery technology, right? And it's many of the same challenges: materials, cost of manufacture, et cetera, right? Whether it's lithium ion, sodium ion, whatever it is. What is your sort of vision, you know? So to some extent, there's some competition between hydrogen and battery, you know, as an approach, or it could be a mix. Do you have sort of feelings about which direction it goes, and what hydrogen versus, you know, building large industrial scale batteries for the same challenges?
Well, I have to think that if you're, let's get this back to a microgrid or very local use. I think battery storage makes more sense in that case to deal with the, when does it become cost ineffective to store energy in a battery, and what is the storage holding capacity of the battery bank? And I think the issue is it's not a long-term solution, and you need, if we're going to have an apocalyptic winter where the sun is blocked out for a long time, you're going to need a large amount of storage, and batteries are not an answer. So we have to look to both, and we should implement both from both an efficiency and the point of use perspective. One of the advantages that hydrogen has, and we have this in Texas, we have a lot of pipelines, many pipelines, right? And they can be, they have to be certified, but they can be used to push hydrogen from where it's generated, if you can do it effectively, and store it in the salt caverns or the storage locations where it's going to be used. So this is the problem of hydrogen is how do you use it locally? So I think this is where I see it more for a long-term energy storage perspective. I don't know if I'm answering your question.
It's hard to store though, right? You have long-term leakage concern. At the same time, if you're talking about long-term storage, hydrogen being effectively protons, right, is really hard to store, right? It'll go through, you know, it's a smaller molecule than anything you build for a tank to go around it or a pipeline. So how big a concern is leakage with long-term storage with hydrogen?
I guess I don't know enough about it to give you an answer. I think the other things that you can consider is if you take, now you have to have a local manufacturing plant locally, right? If you make methanol on site, then you can convert the methanol using using a fuel cell back into electricity on site. And so it's, instead of using petroleum, right, for the fuel cell, you could use methanol. So methanol-based fuel cells are other ways of doing long-term storage. So something that has a high energy density that's liquid, and hydrogen is one of these. Methanol, I'm sorry.
Yeah, may I? Well, this is more for Antonio or even for Ricardo. But what I heard is two things. First, Portugal, together with Germany and Holland, are among the countries in Europe which have more storage capability for gases, okay? REN, this electrical, who runs the electrical transmission grid, and gas also, they only use 1% of the storage. So we still have 99% availability of salt caves storage, which is fantastic for a small country. And then the second thing I ask you to confirm is that I heard Peças Lopes, the author of this paper you were mentioning, or one of the authors, I don't know if you were another one, talking about the daily storage, seasonal storage, so there are different types of storage, and you can combine really.
No, it's exactly that. Portugal uses a lot of hydro energy, but it's very variable. Dry year we have 5 terawatt-hours. On wet year we have 16 terawatt-hours, average around 10, and it has to be compensated. And we see that the seasonal and year-to-year regularization could be done with hydrogen. Otherwise, we'll have to curtail a lot of wind and solar as we are installing it.
So I think the paper that I cited was looking at loss of load expectancy, and if you're so if your house uses a little less power for a day or so, that's fine. But if you're running an industry, right, how can you can't tolerate it? And so this is where it's load leveling and load reliability that where hydrogen, I think, really comes forward, and you know, the long-term storage, and you can use it into the future. So, okay. Oh, we have a question back here.
Last one.
John, question on this is in the earlier slide. You showed looking at the demand for energy on a global mode going forward. Curious about whether the actual utilization of the electric vehicle to essentially get away from the carbon footprint going out or reduce the carbon footprint, whether that's actually generating a larger need for energy than one would have otherwise. One looked at what the cost of actually the utilization of the electric car in place of the petrochemical would be on the overall need for energy in a global mode.
Can you repeat?
I think
I have trouble hearing. I apologize.
Okay, I'll try to
No.
repeat the
He's
question.
going to tell me what you just asked.
See if I understood the question. It's a comparison of energy need between conventional cars and EVs.
Yeah, technically, we're essentially transitioning from the petrochemical-based automobile to the electric-based automobile. Does that actually, in a global mode, is that going to set the demand, a larger demand for energy than it would be if we stayed with the petrochemical going out of it? In other words, what impact is that going to have on this utilization of the global energy need?
Say that again. It's not you, it's me.
Does the transition to electric vehicles drive an increase or a decrease in energy requirements?
I think it depends on the efficiency with which the electricity is generated. And the losses associated with power plants, it's like you lose a large percentage of the energy, thermal load loss. And I don't know what the economic or the sort of the life cycle costs and what is the true cost of the energy, the electrons that you're going to use that come from a power source that's electrons for your car. If it's all going to be fuel-based, then it's going to be a much larger demand, right? You're offsetting the petroleum, but you're using it to produce power. So I don't know the answer to your question, but it really depends on the efficiency with which and the carbon footprint with which you're generating that hydrogen. If you use natural gas to make hydrogen, and you have to do this in a low carbon environment, then you're going to use a lot of energy just to capture and sequester that carbon. So there's a lot of inefficiencies baked into natural gas, blue hydrogen, that they're different inefficiencies than in the green hydrogen. So it's I think a point I want to make, and I'm not directly answering your question anymore, is that when we approach people in Texas and we talk about we like to work together, what is important to the energy sector is that they continue to derive economic value from their sunk costs in all of the resources that they own. So it will be a slower migration to green hydrogen in the state of Texas because of all the energy reserves that are based on natural gas and petroleum. And this is where, like, the hydrogen hub is looking at how do we do this in a low, clean hydrogen, so get the carbon and capture it, right? And so this is it depends on the resources of the region, and because Portugal doesn't have the natural gas resources, right? It's necessarily, I don't want to say forced, but you are, in a sense, forced into green hydrogen much more rapidly than I think you'll find happening in the United States.
Killian?
Thanks, John.
Killian,
Yeah.
I'm sorry to interrupt you.
up.
We have 2 more questions on Slido. I'm not sure if you can read the questions on the screen.
Yes, I'll see those.
Otherwise,
so
I can read that.
I
for
can
you.
see them.
Okay.
Fortunately, I can see them. Yeah. Comment online is amazing keynote. Thank you. If you'd define a big goal or big question for the program to solve in the next phase, what would that be? And I'll read the second question at the same time. To what extent do you think we'll be able to leverage legacy infrastructure, such as natural gas pipelines, to transport and use hydrogen?
Well, I think I sort of answered this legacy infrastructure. It's seen as if you make hydrogen locally, wind farms out in West Texas, right? And you cannot pump electrons far enough to make that cost effective. So you need some other mode of, at the present time, you need some other mode of transporting the energy that you've produced out in the vast reaches far away from the population centers, and the manufacturing centers in Texas are along the Gulf Coast by and large, right? So the pipelines that are pumping natural gas they're being looked to transport hydrogen. So the hydrogen's produced locally and moved, and maybe it's moved in the beginning as a blend and separated at the point of capture, at the point of use, or it's hydrogen pipelines are dedicated directly to hydrogen. But I know this is one of the things that they're looking at from techno-economic analysis. Does it make sense to use these? Can we use these? It's an ongoing conversation from the Permian Basin to the Gulf Coast.
Let's hope it's not a sunk cost fallacy.
Yeah, yeah, it's always cost.
Yeah. Could you bring up, please, just the survey answers? Is that possible? Just to see. So to question 1, in shaping our sustainable energy landscape, how pivotal role do we envision hydrogen playing a role as an energy vector in our collective future? And as a majority of half the votes, it's significant, and then a spread between, it's mostly positive. So most people in this room are believers in hydrogen as energy vector, so I don't think there's much debate there. And in question 2, we are evidently not on track to meet the UN 7th SDG. However, do you believe this pressing issue receives adequate attention and discussion and attention for those empowered? Yes. However, is this a negative question or not? Yes. Do you believe that it receives adequate attention? Here, I'd say the results are more spread out. So I think the half of you are thinking that we need to discuss this further and bring this up in conversation. John, how do you think we could go about that with trying to bring a just energy transition to everybody, not just in the Western Hemisphere?
I'm thinking about this question and the greater issues that come into this. And if you're an elected politician now, and there's supply disruptions, and the price of oil is going up, and inflation is rising, and you can solve this by dumping petroleum on the market. They're going to dump petroleum on the market, right? So they're still committed to the goals, but, we'll just push them off a little bit. This is not, there are larger political implications to the people making some of these decisions, I think, and we have to understand that, not forgive them, but recognize that this is going on. So I think we need to keep advancing the need for, energy transition and sustainable development goals that need to be, okay, you're sort of forgetting about these now, and understand where they're coming from, and accept some of that, but not forgive them for making these small detours, right? And you hope that's not a permanent detour, and that's the issue, I think.
All right, so I think we're running out of time. We need to wrap up this part of the keynote. I'd like to thank John again for his excellent talk and contribution. And I'd like to invite onto the stage Professor José Manuel Mendonça, as he has a special surprise for our guest speaker today.
Well, John, this is a very humble and small tribute to your leadership of the program. It's not like Bob. Bob received from the Minister of
Oh,
Science.
I know. I'm jealous.
Medal of Merit for Science. We cannot do this. But we just offer you something for you to hold and remember. And I hope that you will be remembering this for many years throughout the fourth phase of the program. It's heavy.
I know, I got it.
Okay.
Okay.
Okay. Thank you very much.
Thank you.
And this is because people are important. Thank you very much.
Thank you.